When I started this project, I was pretty unsure if I would ever finish it since I thought it would be pretty complicated, but it really wasn't that bad. There were only a few things that I had to do to make it work. Have the computer always be able to see the board, find out when it's my turn, give Stockfish the board state, and then make the best move automatically off of it. But maybe that's easier said than done. For capturing the board, I made the computer just take a bunch of screenshots. To be honest, I have no idea what each line actually does. I just copied it off GitHub so I could have a decently fast stream of images. Big thanks to this guy's opencv videos, which helped me a bunch throughout the whole project. Now that we can see what is happening on our screen, we can find the location of all the pieces by taking a screenshot of the board and finding the pixel locations of each piece in this list one by one. By performing some magic on the pixels, we can convert them to board locations in the form of coordinate tuples. By appending the coordinate locations of each piece to a list, we now have a way to see where each of the pieces are. For example, the first row of the list shows the positions of the black bishops, and the second row shows the position of the black king, and so on. However, we should really only find out where the pieces are when it matters, which is when it is my turn. All other time that elapses is just time that I can't perform any actions, so we should just wait for when our turn comes to process information and make a move. But how do we find out when it's our turn? Well, as you can see, the timer changes color when it's my turn, so just check for that and we're all good. So now our computer can read the position, which is great, but I need a way to use Stockfish. Luckily, there's already a Stockfish Python library that I can use, which tells us the best move for a given position, depending on the depth, threads, and minimum time you give it to think. The hard part here was translating my stupid piece locations list into a format that Stockfish could actually understand. And my dumbass spent 4 hours trying to use this function, which makes a move in a 4-character notation like e2, e4. This was great except for the fact that I had to capture not only the current but also previous position and detect the move that was made based off those two screenshots being converted into two fat lists. I tried just going through each piece row to find if there were any changes and then append the changes together, but the problem is there can be multiple differences in these big lists, causing lots of bugs to happen. But then, while looking over the website that talks about Python Stockfish, I saw the set position from FES notation function. I initially glanced over it because I thought FES was some fancy thing I would never really need to worry about, but I was so wrong. If you don't know what FES notation is, it's really simple. Pretty much all the info in between the slashes represents a row on the chessboard, and the letters represent the pieces, with the numbers showing the blank distance between them. So all we have to do is just look at the current position when it's my turn, turn it into FES notation to set the board state, and then just get the best move from it. With the best move, we can do some pretty simple pyautogui stuff to click, drag, and drop pieces by converting chess notation to pixel coordinates on my screen. And just like that, a chess clanker has been born.